So not only can you write to a file, you can read from a file. So to write to a file, you need to use the OFStream object. To read from a file, you use the IFStream object. So what we're going to do is write a little program that will let the user enter some data, and then we'll save that data in a file, and then we'll open that file back up and we'll add all the numbers in it. So launch Visual Studio. Now you Mac users have a slight complication in this, in that the code is all the same, but when you're using Xcode, it hides the folder in which the application actually runs, so you can't go and edit your file. You can't go and find your text files the way that we were on Windows, as far as I know. So when you write an application that will open a file and you want to let the user specify the file name to open, and it hasn't been created by your own program, you're going to have to hard code the entire path. And you're probably not used to dealing with the entire path on your Mac, so I'll need to find my little note about that again. Anyways, empty project. Go over to our Solution Explorer, right click on Source Files, add a new item. It's a C++ file. Time for boilerplate. # include IOStream. Let's include string just for general purposes, even though we probably won't use it. And then we're going to need fstream, which stands for a file stream. Public, no, int main, all of our usual stuffs, system pause for the Windows users. All right. Now, just to be a little bit different, we're going to, we're not going to be a little bit different at all. Why introduce conflicting or two competing ideas at the same time? I was going to stick our variables up in a namespace up above main, but nah. Okay. Let's make two methods, two functions. One function is going to be one getting data and writing to a file, and the other one is going to open that file and get the sum of the data from it. So these functions can just be called makefile, a slightly bad name because makefile has a very specific meaning for C programmers. Behind the scenes, there's a makefile that C++ uses that tells it which source code files to make and how to link them together and the name of the executable. But that'll work okay. And then another one called readfile. And in both of these, we're going to pass in the name of the file name that we want to open. So string file name there, put that between the parentheses, and string file name there. And I better add a using namespace std to make those errors go away, or you can just put std : in front of those. Go back down to main. And do this. Make a call to makefile and give it a file name. October 25, .txt, something unique. And then readfile, October25.txt. All right, this program will compile. It'll run. It just won't do anything except pause after it's done. I'm doing incremental development where I get a program that works even though it doesn't do anything, and then I start adding features to it. If I keep my program working at all points, it's easier, you know. I don't want to type 5,000 lines of code, or even 50, and then start trying to figure out why it doesn't work. All right, to open a file, we need to use the OF stream if we're making the file, and an IF stream if we're reading the file in. O standing for output, I standing for input. So you create your file, and then you open it with the .open command. And you pass in the file name. And the file name can include a drive letter. You know, if you're writing to your flash drive, whatever it is, F:, or I don't know what it is on your machine, \, and you could write it out, you know. But we're not making ours nearly that complex. So for makefile, let's declare our stream, OF stream, and I'm just going to call it outfile. That's going to be my variable name. An outfile is equal to, I'm about to mess up, outfile.open, and then pass in the file name. Then we need to make sure that it didn't crash, that we were able to open that file name. So let's see if that file opening actually worked. Why might it crash? Well, we might specify, you know, X:\, whatever, and there is no X drive on your computer. So if not outfile, I'm putting an exclamation mark in front of the word outfile. This is how we check to see if it's open. If failed to open, I'm adding that as a comment, then we're going to write an error out. Could not open, and we're going to print the file name out as well. And we may as well bail out right away. So I'm just going to stick a return statement after that. It's kind of like if there's a problem, just leave the function as soon as possible. That's one style of programming. Another is to only have one return statement down there at the bottom. But I think that this is pretty clear. All right, now that we have the file open, let's do something with it. Let's ask the user to enter a series of numbers with -1 at the end. So enter a series of numbers and a -1 to stop the data entry. You don't have to break it to 2 lines like that. If you don't want to, you can put it all in one string, whatever. So we're going to use a while true loop. I find that to be the easiest when I'm doing data entry. Do we want these to be floats or doubles or ints? Let's just make them ints. Int I, read from IA into our integer. If I is equal to -1, we want to break out of our loop. Else we're going to write that to our file. Outfile, rather than cout, arrow, arrow, that number, followed by an ENDL. Underneath our while loop, we need to close our file. The reason we're going to close our file is basically you want to close your file as soon as possible. Because if your file is open, your backup software may not be able to make a backup copy of it if you have backup software that runs regularly. You won't be able to open it in another program. Generally, your program should open a file, write to it, and close it as quickly as possible so that it's not open. Somebody, unplugs the computer and that file was still open, then it might not be there the next time you come back to it. So we have to close the file. Outfile.close. All right, that's enough to test it. Go ahead and run it again. See if it compiles without errors. See if you can type in a series of numbers. Doesn't matter whether they're all on the same line or on different lines, as long as they end in a -1. And it says press any key to continue. Now I want to make sure that that file was created. So I'm going to go to my Windows search. I'm going to see if I remember what my file is called. Oh yeah, oct25.txt. And there's my data. It's the same data that I entered in on the screen. But since it's saved to a file now, I don't have to enter it again. I can run as many reports on that data as I want. If I want to calculate the average, great. If I want to calculate the sum, great. If I need to come back and edit the scores, I can do that. The user really didn't make 100 on that. They really made a 50. I could open it, edit the data. I can mail this to somebody else to process. That's all the kind of stuff that we use files for. And you already know that, You don't type your resume in every single time you want to print it out. All right. I want to make sure nobody's getting syntax errors. If I have to scroll up or down to get it to work, let me know. Got it working?
Yes.
Good deal. Get yours preset.
Yeah.
Everybody opened their file to make sure that it was actually created. Yeah, good luck on that. I don't know how you're going to find your file. Oh, good. Good. You do know how to do that. That is so cool. Go scroll back up. Going all the way up, all the way up, all the way up. Do add using namespaces to the. I forgot to put that on my boilerplate first. Namespaces. Good. Okay. So now the read file is going to do the opposite. It's going to open the file. It's going to use an I file. Excuse me, an IF stream rather than an OF stream because we're doing input. And we're going to read each line or each piece of data from it. And the loop will look very similar to what we've done in the past, but it's not going to use CIN because it's reading from a file. So we need an IF stream, and let's give that a name like infile. Infile.open, file name. Let's see if it exists. If not file name, excuse me, if not infile, that was a mistake. Then print out an error message and return. Could not open file name. Now we have the file. We can just open it and read in the data. Now they had a specific syntax for finding when you were at the end of the file. And I personally don't remember it. So we're going to write this in such a way that it might generate an error, and then we'll fix it. So let's use a while true again. No, this is not a good idea. So we need to declare our variable, but since we're creating a sum, above our while loop, let's declare our sum, or our total. Set it equal to 0. And I'm making it a double just because, no real reason. So infile goes in to our I variable. Instead of CIN, we're not going to be typing these numbers in. We're going to read them in. And then we're going to add that to double. So total, hey, go away. Total plus equals I. And then let's print out what we just read. Cout, read, something like that, I, just so that we know it's doing something. Now there's a problem here. It doesn't know how to stop. It's an infinite loop. There's no break. Now maybe we could have written a -1 to the end of the file. That's one thing you can do, is you can indicate your own end of file with some specific data sentinel value. But that's not the only way we're going to do it. Okay. 1, 2, 3, -1. That'll be enough. And it gets stuck. It's looping endlessly, doing reading 3. When you need to stop it, just close the program. Hopefully won't give you any grief about that. We're going to go back to the PowerPoint, see the right way to do it. Here's how they do it. I really just like that. While input file greater than number. So let's Google up detecting end of file in IF stream. I could go look at my notes. Sometimes when I do this thing, it's to show you how I solve a problem. There it is, EOF. So we could check to see whether we are done. Let's add that to our code. While not infile.eof. We changed our while statement from while true to while not infile EOF. Let's see if that's better behaved. One, 2, 3, 4, -1. It almost worked, but it read in number 4 twice. So I'm going to give up, I think, and code it the way they did, which is declare my int above the while loop. So do that. Move your int I above the while loop. I need to go back on my notes and see how I did this the last time I taught it. And then we just do while input arrow number. Oh, I know what I'm going to do. Undo all the changes we just did. Go back to having while true at the very top. So make it while true. Leave your int I there. And then do this. Bool OK. And then OK is equal I'm becoming very disenchanted with that too. Okay, I give up. Undo those changes, I apologize. Okay. So we do need to declare I above the while loop, and we need to do this. While in file into I, and then delete that line. That's our final answer right there. I don't like that because it doesn't look like our previous loop. Although we could conceivably modify our input loop to look just like this, except it would have CIN. Then once we're done beneath it, we could print out the total. The reason I was fumbling around on that is because different programs, different languages do file I/O differently. And I was trying to get one that looked similar to ways that you would do it in other languages, such as C# and Java. Because C++ is its own interesting beast when it comes to I/O. But this is the cleanest syntax. It's what the book teaches. It's what we'll use. So never mind.
So that whole while loop is just a count to add everything together?
Exactly. It reads in each line of data from our file,
Okay.
adds them all up to the total, and then it prints the total.
And that's the sole purpose of that while loop?
Yep.
Okay.
Yeah, this shows how to process an input file. Whatever happens between here, is your choice. But we've opened the file here, and we have a while loop that reads it in over and over and over.
Okay.
So the homework is going to be based on this. And I don't really want to give it to you now because you'll, start working on it now. But really, y'all are grown-ups. You'll know to keep watching a lecture rather than that. So write a program for entering test scores and calculating results of the scores. The scores should be saved in a file. When you run the program, it should look like this. Welcome to the test scores program. You don't have to put that or whatever. What do you wish to do? 1 equals create file. 2 equals read file. And I'll post this. You don't have to type all these notes. So say you choose 1. Enter file name. And you type scores.txt. And it'll say enter a series of scores with -1 to stop. So you enter scores. 10.5, 99, 100, 4.2, and so on, and then finally -1. Then it should do this again. What do you wish to do? Create file or read file? What do you wish to do? Create file, read file. 2, I'm going to read a file. Enter file name, : scores2.txt. Now that file doesn't exist. So, error, could not open scores2.txt. Then lastly, again, what do you wish to do? We want to read the file. This time we're going to give it a good file name. Enter file name, scores.txt. It should read all of the scores, total of scores is equal to, and since I picked all these random numbers, I'm not going to be able to, you know. Yeah, whatever. It's not the correct value. Average is, note the total in the average. It's not right at all. And we should offer an option of 3 is equal to quit. So lastly, it'll say, what do you wish to do now that we've calculated the total and the average? And if we choose 3, it'll say, okay, goodbye. Does that make sense? I'm not giving you the exact big description here, because instead I'm showing you how I want the program to work. But you can see that it's really similar to what we did already, right? What's the only difference? Or, well, there's a couple of differences. But what are the differences between what we've already done and what this is asking us to do?
Calling the option to create a read.
Right. And it's letting us loop. So we're going to have to do some kind of loop, some kind of while loop. And then it needs to print this little menu. Create file, refile, or quit. And then based on whether they do 1, 2, or 3, you know, you have an if statement or whatever. If they type in 3, you return or break or something like that. If they type 1, this is very similar to what we had already, except they need to enter the file name. So you're going to have an additional, you know, question. Enter the file name and then let them type that in. That's not hard. You know how to do that. You use cout to ask for that. You use cin to read into the file name. That's the same, except these are doubles rather than ints. Just change that int to a double and you're good. Then what do you wish to do? They choose 2, the same thing. You're going to ask them for the file name rather than hard code it. And then that code that we wrote would print an error message, so that's going to be very similar to that. Once we've printed that error message, it's just going to display the menu again because they never chose to quit. What do you wish to do? Read file. We're going to read into CIN, or using CIN, we're going to get the file name. It will open that file, get the total of the scores. If you want to print them out just like we did, that's totally cool. It'll print the average. You know how to calculate the average. You just keep a track of how many scores you've read in. Where would we do that on our code? We would do that right here in our loop. We would need some kind of counter. You know, int scores is equal to 0, but each time we read one in, we would want to add 1 to it, scores plus plus, so that we could use the calculate the average, something like that. Does that make sense? Okay. I saw some people nodding yes. I didn't see any panicked waving of hand no, so we're going to assume that that makes sense. They have samples of letting the user specify a file name. Here's a mention that if you're going to open a file, older versions of C++ cannot open file names that are stored in strings. So you have to convert that string into a format that it understands. They show you how to do that. We are using a new version of C++ that was invented after 2011, so we don't have to worry about that. Breaking and continuing a loop. I think we've been doing this already. We know how to break out of a while loop. Have we used the continue statement yet? The continue statement is used so rarely.
Yeah, you showed it.
But I showed it to you. Okay, yeah. So just as a quickie reminder, we could do this. Here's where they're entering a series of numbers or -1 to stop. Say there's a secret number that causes the data not to be written. We don't want, we're hacking into our own code, and if they enter a 0, we continue. That 0 would not be written out to the test scores file. Break tells it to go down here and exit the loop. Continue makes it go back up here and do it again. So each time they entered a 0, we would never get to that point. Obviously, we're not going to leave that in there, but you have that available to you if you need it. You can usually code without it. As a matter of fact, I recommend trying to code without it. But if your code starts looking really ugly and then you think, oh, I could have used a continue, then go for it. So that's the end of chapter 5. Our first exam was over chapters 1, 2, and 3, correct?
Don't remember.
Yeah, let's look it up. Yeah, I don't say, did I? Well, the fact that I see Unit 4 and 5 in that Dropbox, in the notes, makes me think that those two things are in there. Have we done enough to have a second exam? How are y'all feeling about it? Do you want an exam now or one more chapter in it? And when I mean now, I don't mean today. Like maybe, Tuesday of next week. Nobody has an opinion. All right, we're going to cover one more chapter before we have the second exam. Do I agree with that? I guess I do. Now let's go ahead and do it. Let's set our exam for Thursday of next week. We'll have plenty of time for you to do the homework and review for it. That way we have a smaller chunk of knowledge that we have to test on. Any objections? No. You're allowed to object. Let's see. No, I want more. Please cover more material. Okay. So, we will make a note of that. Next Thursday, that is the 3rd, November 3, over chapters 4 and 5. Y'all are feeling comfortable with the material as we have covered it, right? Nobody's really getting lost. Everybody's been turning in homework, I think. So, okay, functions. We just used functions in that last code that I wrote. Let's go back and look how the function was declared in our code. The way you declare a function is just the way you declare main. It doesn't have to have the word void. It doesn't have to have the word int, but it has to have something that tells you what it's going to return. It's got to have a data type. And if it's not going to return anything, you use the word void to say that it's not going to return. That's different from Python. You Python users did not have to define a data type for your function. You just use a def keyword. Def, makefile, whatever. And you did not have to say, oh, it's going to return an int, or oh, it's not going to return anything. But we have to now. So that's the way you do it. You give a keyword that indicates the return type. String, int, double, char, or void. So we're going to write a function called addTo, and all it does is it takes two integers and adds them together. So int z is equal to x plus y, return z. Now we're going to write a function that adds three numbers.
Is that supposed to be x plus y or x plus z?
You're right, that's supposed to be x plus y. Thanks. int A, int B, int C. I'm just choosing these variable names totally at random. So int Z is equal to A plus B plus C. Return Z. If I wanted to use those functions down in main, I could. I don't know about. We should have actually started a new program. Take these two functions we wrote, add2 and add3, cut them and paste them right above main. Now we're adding some junk to our file, but hopefully you'll be able to make the distinction. And when I post the homework, I'll strip out the garbage that we're adding. So, int x is equal to add2, 10 and 20. Int y is equal to add3, x, 30 and 40. And then we could print out x equals and see out y equals So looking at this code, what is x going to equal after we run it? Yeah, it should equal 30. What it will do is it will invoke, that's our fancy term, the add2 function, and it's passing in two arguments. Arguments are the data that you pass into the function. So processing will zip up here, and then it will run the body of the function. Now that we're inside the function, we don't call them arguments anymore, we call them parameters. X is a parameter and y is a parameter. A parameter is a variable that's declared between the parentheses in your function definition. This is the definition of the function. In Python, you actually use the def keyword to define your function. You don't do that in C or Java. But now we have two parameters, x and y. We declare a local variable, z, and we use it to store the results of the two parameters added together, and then we use a return. If this was a void, we would not return a value. It would not compile if this was void. It would give me an error. See? It says return type does not match the function type. But there we go. So it would return the value of those two numbers added together, and our arguments were 10 and 20. So x is equal to 10, y is equal to 20. They get added together. Z is equal to 30. That gets returned. Then, now that we return, 30 gets copied into x. So what will y equal when the add3 function is done? Yeah, it should equal 100. Because we're passing x in as the first argument. So a will equal 30. A will equal 30. The b parameter will also equal 30. The c parameter will equal 40. And 30, 30, and 40 are equal to 100. We return that value 100 so that it can be copied back into y. And I'm just going to stick a return 0 statement right here and hope that it'll let me compile the rest of it. No, that's not going to work. I'm going to add a system pause here. I don't know what the Mac user is going to do. Anyways.
Just comment it out.
Yeah, there we go. 30 and 100. So to define your function, you need a data type, which can be void. You need a function name, and you need a parameter list. If you're not passing any data in, you don't put anything between the parentheses. Then you have a body of your function. And after your at the bottom of your body, you should have a return statement if it is not void. If it is void, you don't have to put the return statement, but you don't get an error for doing so. So let's do a function that doesn't accept a parameter. And it doesn't return anything either. So this one's just going to be called say hello. And all it does is say howdy. It doesn't even need a return. So I can call the say hello function like that. I don't have to pass it any arguments because it accepts no parameters. I don't have to store its returned value in a variable because it doesn't return anything. There we go, and it says howdy. If we set a breakpoint on it and ran it, we would see how it works. I mean, we already know how it works, but I'm going to go ahead and do start debugging. I set a breakpoint by clicking on the border over here. It stopped at this line. This indicates our current line. Debug. Where's the go to next line? Step over or step into. If I step into, it's going to actually go into the say hello function. If I do step over, it's not going to go into it. It'll just skip to the next line. So I'm going to do step into. Now I'm here. Now I'm going to do step over. These are also buttons up here. Step into, step over. So I step over. Now it's about to print out howdy. I do that, it actually prints howdy. If I go and find my application, I'll see the word howdy there. Now I'm at the end of it. So if I do step over one more time, it leaves it, and now we're back here. We're going to run this line. Now let's say I'm not interested in the add to method, so I'm not going to do step into. I'm just going to step over it as well. Step over, all right, now I'm done. It did that. If I hover my mouse over X, it might tell me the value of X. X is equal to 30. Also, there's a variable list down here. We could find our variables if we drag this up. Right now we have two variables defined, X and Y. X has the value 30. Y has no value yet because it hasn't been assigned a value. But let's say that I was interested in Y. So I'm going to click step into up here. Now I'm in the add 3 method. Then I decide, oh, I really did not want to see this one. So I'm going to click step out. What step out does is it runs the whole function and then pauses at the next line. There we go. So I did step out. It did all of that stuff. And then if I do step over once more, then it copies the value that add 3 returned into Y, and Y is equal to 100. Then we could print each of those things out. So you see how the functions are working. When you use functions, sometimes you need to define them with a prototype. And I'll show you what I mean. I'm going to go all the way to the bottom of your code and do void say hello to cout hello hello. When you're done with that, go back to your code and add a call to say hello to right under your call to say hello or whatever we called it. And then try to run it. You won't be able to compile it. This is different than in Java. If you've ever done Java, once you define a function, it's available to any other code in that same file without doing what we're going to have to do, which is define a prototype. Or we can move this above main. For C++ to be able to compile this code, it has to know what this function does. Not what it does, but if it takes any arguments and if it returns anything. Without that information, it can't compile it. So now that I'm going back up here, I'm going to get rid of that breakpoint. I'm going to add a call to say hello to. It's not giving me an error, but wait until I build it, try to run it, start debugging, and I get an error down here. And it says error. Say hello to identifier not found. That's like doing this, kind of. X is equal to 3. Well, we've already got X and Y. Z is equal to 3. Don't type this. Int Z. You know? We're trying to use Z before we've defined it. We're trying to invoke say hello to before it even knows what say hello to is. It can't compile it because it doesn't know whether we're supposed to be passing any data or not. It doesn't know whether it's supposed to be returning a value. But we can add a prototype that will fix that. The prototype is the function definition without a body. So it's the function definition, including the parentheses, but just ending in a semicolon. Like that. That's our prototype. Now it should work. Oh, 2 errors rather than 1. Oh, that's because of that code that I added. Z. There we go.
So why would you do that? Why would you just not add the function above the main?
What if you have a more complex web of needs, of functions and calling other functions? It might be difficult to arrange them in an order. A more important reason is, what if these functions were defined in another C file? A large project could have hundreds of C files. And so what you do in that case is you move your prototypes into a header file or multiple header files that you can bring in. For these programs that we write in the class, the code is so simple that you're probably not going to need very many prototypes. But that's why you use them. It eliminates the need to arrange your code perfectly in order to get it to compile, and it lets you put the... Okay, so let's make it so that these other functions, add to, add 3, and say hello, are also at the bottom of the file. So copy add to, and I'm just using shift down cursor, add 3 and say hello, cut those, and paste them at the bottom. That breaks our code. We need some prototypes. If I tried to run it, we would see that we got errors. So we need to put some prototypes in it. Now, say hello did not accept any parameters. So that's its prototype. Add to did accept 2 parameters, and it returned an int. So int add to, the easiest thing to do is actually just to copy that header and come and paste it rather than try to recreate it from memory. And it takes 2 ints. Add 3 returns an int, and it takes 3 ints. Notice I didn't give it variable names. You can. You could put int x and int y, but you can also leave them out. Is there an advantage to leaving them out? Not really, but you'll see a lot of code examples out there that do that. To me, I think the parameter names actually convey important information. I'll give you an example. Don't type this. But if my prototype was this, double calculate area, and I just did this, double, something like that, you wouldn't even know what these things were. But if I gave it, good values like height and width, all of a sudden you know what those things are. So it makes it easier, to follow somebody else's code if you don't leave the variables out. But you can. I'm calling them variables. They're actually parameters. Now that I've added my prototypes back in, it should run. I'm going to clean up my code by moving those parameters into a header file. So once you get your code going, if I get any syntax errors. Sure. So I'm going to take those 4 lines, I'm going to cut them, and I'm going to create a header file. Highlight, cut, or maybe I should just do a copy and delete them later so I don't accidentally lose them. I'm going to right-click on Header Files and do Add, New Item. And it's a header file. What do I want to call it? Well, header.h is okay. Hello.h, I just have to remember what I called it. These are sample functions, so I'm going to call it sample.h. And then I paste those things into sample.h. Then I go back to source.cpp, and along with my other include statements, I do include. I don't use angle braces now because this file is in the same directory as source.cpp, so instead I use quotes, and I make it include sample.h. Why do you use header files? Like I said, you may have a complex project with dozens of files. Or you may want to share your code with somebody else. So you make a header file that defines the functions that are in this code. And so in order for them to run it, all they have to have is the header file. They will also need the CPP file unless it's been compiled as a DLL, which stands for a Dynamic Load Library. If it's compiled as a DLL, then you don't even have to give them the source code for the functions. But we certainly aren't there yet. When you go and you start making classes, you will always have to define a header file for your class in this language. Java does not require header files at all. Java doesn't even have the concept of a header file. All right, so that's all we need to know about functions. We're done with this chapter. I'm kidding, but let's go look. That's not right. Didn't I download chapter 6? No, I didn't. Okay, along with chapters 4 and 5, functions up to the point where we have discussed them today will also be on the exam. And we'll do a review of the exam on Tuesday. So modular program is breaking a program into smaller manageable functions or modules. I showed you that already on that makefile and that readfile. Those are 2 modules. when you write your own program to do the homework, you don't have to break your code up into modules if you don't want to. But it would probably make it easier to structure. What do I mean by that? If makefile was not in its own code, in its own module, don't do what I'm doing, then the project would look something like this. I'm taking the guts out of readfile and writefile, and I'm pasting them into main. Okay, now all of a sudden main is huge, and there's no real clear distinction between the two things that it's doing, between the reading and the writing. You know, so it's one big ugly mess. I'm going to undo that change. I hope you would agree that by breaking them into two functions, a makefile function and then a read function, it made the code a little bit easier to understand, even though you may not have been familiar with writing modules yet. Now you are. So in order to actually use makefile, you just invoke it. Like, where's my main? I have messed this up. There, like that. You call makefile, you pass in a file name, boom, it's done. Or you call readfile, you pass in a file name, boom, it's done. Makes your code more structured. That's called modularizing your program. So a function is a collection of statements to perform a task. We've written a couple functions today. We wrote a makefile function. Its task was to open a file, ask the user to enter some data, write that data to the file, and then close it. Then we wrote another function called readfile. Its function was to open the file, read it line by line, adding up all those numbers and generating a sum. Your motivation for modular programming. It improves the maintainability of the program. You can tell your coworker, hey, my makefile program is broken. Could you go look at it? They can zoom in right on that method, right on that function. And there may be thousands of lines of code in your project, but you can tell them which function it is, and they can go look and they can go fix that without worrying about the rest of it. And it says it simplifies the process of writing the program. It certainly simplifies the process of debugging it once, if you have a problem in it. Here's their example. You have a main, and it's got 12 statements. That looks more than 12. Here's how they broke it up. Main, and then you stick some of that code in a function 2, and you stick some of that code in a function 3, and you stick some of that code in a function 4. Now, realistically, main should call function 2, function 3, and function 4. But you get the idea. You're breaking it up into blocks. A recipe would be hard to follow if it was all just a single paragraph, with 10 steps on it, but there were no spaces between it, no nothing, Defining and calling functions. A function call, also known as invoking a function, is when you cause the code to execute the function. And so to do the function call, you give the name of the function, you do the parentheses, and if it takes any data, you put that between the parentheses. And if it returns a value, you put an equal sign in front of it and a variable name in front of that. And then the function definition is the statements that make up the function. I think we should just about stop here. We've already talked about how you define a function. You give it a return type, int, double, void. You give it a name. Then you have a parentheses, and inside the parentheses is a parameter list, if anything. And then you have a body. The body of the code is the stuff enclosed in the square brackets, braces. All right, let's make a Dropbox for today's code. We will call this file IO and functions. Did I just say that out was J, so this will be K. So this is our makefile and readfile code. Go ahead and upload your CPP or your project zip into K. I put that in the wrong folder. Un momento. Okay. And I will write up that homework in the form of a Word doc and post it as homework 8. We'll make it due on Monday 9. This is a low energy class. I need to give some of y'all 5-hour energy drinks so that y'all make lots of noise. Hopefully that'll be an easy program. You know, I didn't really want to load y'all up on Halloween weekend with too much work so that y'all could have fun. But if you get stuck on it, please let me know. So I would start working on it before the weekend unless you just really can't. And if you need more time, you can always just let me know.